Okay, hello and welcome to today's free, it says GRE GMAT prep hour. Thank you very much. GMAT prep hour. Today's focus is quant speed strategies. And I did do a series of these for the GRE, and that's where that came from. And I thought I would do it again for the GMAT since there's some different strategy you want to do there. But a lot of the things we want to think about are the same across both of these tests. So we'll go through a few different ways to think about how to pick up speed. Speed is tricky on the test because we don't just want to be fast, right? We want to do a good job, and with an adaptive algorithm, it gets very, very tricky to think about that. But we want to make sure that we're not running extra long on problems, that we know where to pick up time. And, often being able to do a difficult problem in 2 minutes is really just being able to take easier problems and crunch them down where you can do them in, say, 30 seconds or a minute, so that a larger problem that's a combination of several things, no one of those things is so hard that it eats up all your time. And so getting faster is partly just a way of taking things that were previously impossible and making them possible within the scope of the GMAT. And it's also making sure, of course, that you don't fall behind. So some broad strategies here. First thing, you want to front load your efforts. And this is across both quant and verbal. I think one of the most important things you can do on this test is do more work up front. And that looks different in quant and verbal, what that looks like. But that's going to be a major theme across really any preparation you do, is how do you do better at the beginning? It's funny because last month I did a workshop called Problem Solving the First 30 Seconds, and I'll mention that again. And when I went to look for it on YouTube, I realized that my colleague Whitney had done one called The First 30 Seconds like a couple of years ago. And I was thinking, wait, did they mislabel? Nope, no, we both had the same idea, because the first 30 seconds are such an important part of your process. And so if you want to check out one or both of those, thinking about what we do at the beginning is very important. One of those elements that I want to really, pull out and highlight is the idea of making predictions. Sometimes we really can't make a good prediction. Sometimes we don't know what we're looking for. But other times you can have a really strong idea of what the answer should be. Sometimes so strong that you don't have to do the work and you can just, oh, it's B. A is too small and C, D, and E are too big, right? That can be an estimate. It can be a property of the number we're dealing with, but something that you need to know. We're going to want to get better at recognizing bad answers. When is an answer nonsensical or just simply too good or too easy to be true? We want to avoid unneeded work. You don't want to calculate if you don't have to, whether it's data sufficiency, problem solving, what have you. And that also applies in verbal as well. I don't want to dig in and really understand some concept in a reading comp passage that they never asked me about. So maybe there's some things I need to set aside understanding until I find out if I really need to understand them more thoroughly than I did. And also across both quant and verbal, you want to develop a whole section strategy. You don't just want to think about how I tactically handle one individual problem at a time. I want to think about, what does it look like to complete an entire section? Where are the parts where I tend to slow down? And this is tricky on a test that's adaptive, right? As you do better on the GMAT, the test gets harder. And so a lot of people slow down at the beginning, really wanting to get things right so they can ramp up to a higher test. But the problem is that if you're falling behind to do that, now you've been given harder problems and less time to do them, and it's not sustainable and you crash. And so thinking about how that plays out across the whole section is really important. So I want to fill a couple of those things in, and of course, jump in on the chat if you have questions, comments, whatever about any of those things. So in terms of some of these individual elements, one thing we want to think about when we're front loading the efforts is clarifying the question. And I think in some ways, this is the single most important thing out of all of our strategies, is make sure you're answering the question that they asked. That sounds so obvious that it seems silly or even patronizing to mention. Well, of course I should, answer the question that they asked, right? But often we're not doing that. And in real life, we can get away with answering variations of people's questions, right? We might not always answer people's questions precisely, but they're just making conversation and it's no big deal. But on the GMAT, if they ask you about X plus 1 and you answer X, if they ask about Y and you answer X, whatever it is, if you're a little bit off, if you haven't recognized what the question prompt is asking, and verbal, it might be the difference between, wait, am I supporting the argument or is the argument supporting an answer? Is this a strengthened question or is this an inference question? This is surprisingly often where the trouble happens, right at the beginning. On data sufficiency, that often means rephrasing the question. The question can be very simple. Hey, what's X? But it can also be incredibly complicated. And sometimes we don't really know what they're asking until we sit and do some work. That can also involve making a solution expression, right? So for instance, I want to know the average sales for January through March. I might write something like, hey, I want J plus F plus M, and I want the average, so I'm going to divide it by 3. And I might write that on my paper before I forget, before I get off into other things, because I would hate to, at the end, accidentally just put the total and never divide it by 3 or anything like that, or solve for the wrong thing. Maybe I'm going to make an actual table instead. Maybe there's like a before and after. And then there's like, 2 people like this. And then, we want to know how much Jen had after she traded with Kevin. And we know that she added 10 or something like that. And so we fill in those columns and we box them like that. So having things that keep you on track to answer what they ask, that in itself can make a really big difference. And as you've probably seen on this test, when you miss lower level questions, you get knocked down and you never get to see those more challenging questions. And so a lot of people focus all their attention on how do I understand and master harder and harder questions, when what would drive their success more would be, how do I make sure I'm getting the ones right that I know how to do? If I already know how to do something, and if I already have the skills and the understanding to get it, I don't want to miss it. And so I want to make sure I don't do something like write that slides are for the GRE when they're for the GMAT. I don't want to make mistakes like that, because that's the kind of thing that can really get me. And often those are right at the beginning. And that's something to keep track of. Predictions are also a big part of this, right? So even when I'm going to do all this out, this is important. In fact, I had someone in my 30 seconds workshop say something along the lines of, do we really have time for this? You're telling me to think about estimating and predicting for 30 seconds or within the first 30 seconds, and then I'm going to solve. Shouldn't I just save time and just go straight in and solve and not worry about that? And I said, absolutely not. I think there's a lot of redundancy in this work, and we want to have an idea of what the answer should be before we do the work. A lot of the time. Can't always do it. But if I know my answer has to be greater than 20, then when I accidentally get 12, I know something's wrong. And sometimes when I predict or estimate, I actually can see what the answer has to be, and I've saved myself a lot of time by having to solve. So sometimes I'll still have to do the full solution, but it'll keep me more accurate, and it'll make me more certain that I'm right because I got the right answer, 2 different ways. Other times I'll predict or estimate well enough that I don't even need to do the full solution, and that's wonderful when it happens. We pick up those extra minutes. Recognizing bad answers is also partly about estimation, right? I can just tell an answer is too big or too small. If I ask you for something like, what's the population of Spain? You might not have a very clear idea. Maybe you'd be off by quite a bit. But if you saw answers in the thousands or in the billions, you'd say, okay, those are too small and too big. And so sometimes, depending on the size of the answers, estimation can be, a fairly easy way to knock things out. Sometimes I have to be much more precise, and I'd have to know a lot more to be able to narrow that down. But working on estimating, you'd be surprised how often that makes a difference. There's also some topic-specific things you can do. And that's going to be something where, as you build notes on individual topics that you're studying, you can start to notice, oh, when I'm doing a probability question, here's a way I can knock something out, or here's some things I can recognize. Here's something I know about rates and work. Sometimes it's as simple as, this is a big one that people never, well, not want to say never, but often fail to realize, is that percent greater and percent less never match. And what I mean by that is, if I'm 20% heavier than you, if I'm 25% heavier than you, I almost put greater. I'm not greater than you, geez. Then the one thing we know immediately is you are not 25% lighter than me. They never match, right? In fact, I'm 5/4 of your weight. You're 4/5 of my weight. You're 20% lighter than me. And that might be apparent to you. But the idea is recognizing those topic-specific things and recognizing that something's a trick or a trap and saying, wait a minute. The one thing I know is if Dmitry's 25% heavier, this other person is not 25% lighter. And in fact, the less number will always be a smaller percentage than the more number. And we can use that to narrow things down. You automatically know, even if you didn't know the 20%, you'd automatically know if someone is 25% more, the other person, the percent less they are is less than 25. It's got to be a number less than 25 automatically. And that's true whatever the number is, right? If I'm 50% heavier than you, then you're 33.33% lighter than me. What we know for sure in advance without doing the work is that you are less than 50% lighter. It's not a full 50%. Okay. And other things, scanning the answers and problem solving can be really useful. What I try to do a lot of times is slow people down on looking at the answers in verbal. In fact, in our courses, we talk about taking a first glance, and I kind of push back on that and say, don't even take a first glance at the sentence correction answers in verbal. Wait. Understand what you're reading, understand the initial sentence, break down the core. In reading comp, make a prediction of what you're looking for. In critical reasoning, identify the structure and the assumptions and all those things. But in quant, sometimes it's good to just take a look at what am I dealing with? Are there radicals in the answers? Are there exponents? What kind of form are these in? Are we going to have to simplify all the way? Are there variables? Can I maybe pick some numbers? What do the answers tell me about what I might want to do? And when I do that, then I might be able to better knock some things out once I've made sense of the problem. Other things, avoid unneeded work. And this, a lot of what we've done already, talked about already, those are ways of doing that. But one of those things is calculate only as much as you need to. If you find yourself doing a lot of, say, long division, it's good to remember how to do it, but you shouldn't be doing it very often. And even if you are, you might not need to get all the way, right? Maybe you're doing something like 27 into 8,500. And you don't know exactly what that is, but you say, let's see, 27 times 2 is 54, times 3 is 81. Oh yeah, that's like 9 times 9. So it goes 3 times into 85. So I'm going to subtract that. And maybe that's enough, right? Because maybe by the time you do this and start pulling out a 0 or 1 and this and that, maybe you already know, okay, but it's somewhere around 300. And maybe that's all you needed, right? So it's not going to be exactly 300, but it gets you enough of an idea that you don't need to do the rest. So don't calculate more than you need to. Especially in data sufficiency, where as long as you can calculate and get one answer, who cares what the actual answer is, right? So getting used to not doing excess calculation just because it's there. Getting by tough algebra. There are places where you can pick numbers, where you can work backwards, where you cannot have to set up abstractions. Algebra is one of the greatest inventions of humanity. I love algebra. I work with it all the time. I teach it. It's great. It's beautiful. But it's designed for cases where a quick intuitive version is not available, right? If I say something like, Don is 30 years old and Carol is twice as old as Don, you would never set up equations for that. You'd say Carol is 60, right? You wouldn't say, C equals 2D and then plug in, D equals 30 and do all that. You wouldn't do that because your brain could just take care of those numbers, right? Because it's concrete enough and because the relationships aren't complicated enough. So we use algebra when we're not able to do it another way very readily. But when there are ways to get around it, we don't bother with the algebra. I think that kind of thing is very important. And then finally, in terms of developing a whole section strategy, some things about that. First, know your benchmarks. How are you going to be planning this out? Don't go in and take a practice test, even let alone a real test, without knowing where I should be at each problem, where I should be time-wise at each sort of check-in. And you can have different forms of check-ins. Different people, push different methods. The link I have here on the screen is our timing blog. If you just look up, Manhattan Prep GMAT timing, you can also find that. And we talk about our method of benchmarks, which I'll flash up really briefly. But the idea is basically checking in. You want to be mostly steady. Like I said, you don't want to try to slow down at the beginning and try to get a lot right. You also don't want to rush through and miss things you don't need to miss. So you want to keep a more or less steady pace. Sometimes people, when they're really maxing out quant, when I see people who are getting, say, a 46 plus in quant, which, most folks don't get, but it happens. Then sometimes I see a little bit more room where people are able to do even some pretty hard problems quite quickly. And then they have room to maybe run to 3 minutes on some other problems. But usually we're trying to stay pretty close to that 2-minute mark. And with the occasional bail that we're doing, right, letting go of some things, and we should do that, fairly often. Giving us room not to run really long on other questions, but to spend an extra 30 seconds here, an extra 20 seconds there to solidify our score. And it's important to remember that, especially in quant, verbal is a little bit more finicky about how many you can miss. But especially in quant, the expectation is that we're going to miss, unless we're really maxing out, we're going to miss almost half the questions. And because of that, it is okay on any given question to say, I'm not sure. Especially if you can narrow it down. If you know the answer is A or B, but it would take you 3 minutes to figure it out if you could even do it, then great, take A or B and get out of there. But even if you have no idea what the answer is, it's better to pick something and move on than to spend a whole long time torturing yourself on something. Especially because we find when people run long, when people spend 3 or 4 minutes on a question, usually they are getting it wrong, because we usually run long on things where we're having trouble. Right? And so it's important to know that. So know your own personal skip cues. Are there question types that you just don't know how to do or don't feel comfortable doing, or that you always miss? Are there situations you find yourself in? Oh, I've written an equation, but I don't know what to do with it. Or I get stuck at a certain place where I kind of know it's not going to get me done in 2 minutes, and know when and how to tell that you're going to get rid of a problem. Accept in advance that you will pass up on problems. Most of us teachers do the same thing too. I don't know if I've talked to a teacher who said, oh yeah, I just did the best job I could in every single problem in quant. I don't really hear that often. And these are folks who have really got this down. So just assume you're going to be bailing on some questions. It's just a matter of which ones and how do you tell. Okay. Questions on any of that before we move to other things? We're going to get to some problems in a moment. Okay. In terms of benchmarks, I'll let you look at that blog post if you haven't seen these things already, but just I'll flash it up here. The yellow pad technique that we push in class, this is for in-person testing because you don't have the yellow pad available if you're testing online. You have a whiteboard, but would be marking up your pad in this manner. And basically it's quadrants and then 3 on the first page. I won't go into detail about it because we do that elsewhere. But the idea would be that you're checking in and you're saying, okay, after the first 3 questions, I have 56 minutes remaining on quant. After the next 4, I have 48. And this is something to get used to in advance. If you find yourself behind, drop something to catch back up. If I'm here and instead of being at 40 minutes left, I have 36 minutes left, I don't want to assume that I will catch up later because it's very unlikely that I will. Instead, I'm just going to drop something on the next page. It doesn't have to be the very next problem I see, but I also don't have to wait for some like terrible problem. I just look at one and say, this looks a little long, or, oh, overlapping sets, I'm not crazy about those, drop. When you drop a question, you're not saying, I don't know how to do this, I'm not smart enough or good enough to do this. You're simply saying, something's got to go. I don't have all the time in the world. I'm going to drop this. Right? It's almost like if you had a bunch of stocks and you needed some cash, and you were like, I'm going to sell off some stock. What should I sell? When you're selling one, you're not necessarily saying this stock is a loser and no one's going to make money on this. You're just saying, I need money, so I'll cash something out. I don't want to say it doesn't matter which one it is, but it's not an essential decision, right? It's more just like drop something so you can get back on track. Okay. If you don't want to use the yellow pad technique, or if you're testing online where you don't have the availability to use the yellow pad technique, you can also use a simplified system of benchmarks that you just memorize. For quant, it can be very simple, just 5 questions in 10 minutes. So this would be, instead of kind of counting up and marking, you're counting down from 62 to 52, 42, et cetera. Verbal's a little lumpier because you've got 36 questions in 65 minutes. So I often recommend 5 questions every 9 minutes. You'd be counting down from 65 to 56, 47, 38. So if you want to, write these down at some point or memorize them, you can. This is an alternative that you can use with the online whiteboard, or not the online whiteboard, the physical whiteboard for the online test, or that you could even memorize to use on the in-person test if you'd rather not divide up your yellow pad. But the idea is, no matter what your system is, no matter what the time markings are, or whose idea it is, or whether you write it down this way or that way, anyone who's taking the GMAT should have a timing plan and should have some benchmarks in mind so that they're knowing when they're behind, especially if you're not really keen on stopping and doing a bunch of mental math during your section. I've done it. I've been there going, okay, let's see, I just finished number 13. So 13 times 2 is 26. So that should take 26 minutes, and 62 minus 26. But do you really want to do that during your test? Even if you're very comfortable with mental math, do you want to be spending your time doing that during your GMAT? Probably not. So having a system of benchmarks and sticking to the benchmarks like they are religion, right? Like they are sent down from the heavens is really important. Don't let yourself fall 3, 4, 5 minutes behind. It is very unlikely that when we do that, we will have a comfortable recovery. Usually it means that we crash a bit at the end and we underperform, or we panic and rush, and that's often even worse because we end up missing more than we need to because we're spending maybe a minute and a half per problem instead of 2. We're not really catching up much, but we're also missing way more problems than we otherwise would. So don't panic, don't rush, don't crash. Instead, try to avoid being behind in the first place. And if you do fall behind, drop a single question at a time to catch back up. Okay. So let's apply some of our speed strategies to some problems. So the first thing I want to talk about would be the upfront stuff. Can I clarify the question? In data sufficiency specifically, can I rephrase? Now, folks who are attending live, I know are both familiar with the idea of rephrasing data sufficiency questions, doing data sufficiency questions. If you're watching this video, you haven't seen data sufficiency before, you can give that a quick refresher before we talk about this. But the basic idea is that we're going to look at a question and say, how much information do we need to answer this, right? And we always mark our answers using the format of ADBCE. So this is another upfront work you do. If this is unfamiliar, this is worth looking up. But what I want to talk about is what kind of upfront work we can do before we tackle the statements, before we tackle the answer choices. When I see X equals 3WY, and I want to know what the value of W is, what should I do first? Yeah, we're looking at what we should do first, and I'm seeing rephrase this, right? So if we want to know W, let's isolate W and see what that's equal to, because what we're trying to figure out in data sufficiency is what information do I need, right? So if I want to know what W is, I can say, well, let's see. If I divide both sides by 3y, I could say W equals X divided by 3y. So that's what we're looking for. What is that, right? I know that W is X over 3y, but what is that? When they ask for the value of something, they're not saying, hey, tell me what it is in terms of X and Y. They're saying, is it 5? Is it 9? What's the actual numerical value? So when I look at this, I can say, all right, one simple rephrase would be, what's X over 3y, right? That's what I really want to know. If you look at the answers, if you scan out the answers, the statements, if you scan the statements, you'll notice, maybe not too surprisingly, neither of them mentions W. It would be kind of easy if they asked you what's W, and then statement 1 said something like, W is 4, or statement 2 said something like, 2W squared is 32 or something like that. That would be a little simple, right? So they're probably not going to do that, right? One of those would be sufficient, telling you W. The second one might look sufficient. It would be consistent with W being 4, but it would allow for 4 or negative 4. So it would be insufficient. But that's not usually what they're going to do. So instead, we want to be able to get this X over 3y. If we really want to be savvy, we can save some money to work. I don't actually care about the 3. If I know what X over Y is, I can always divide by 3. So my true rephrase to save myself from some additional work is, what is X over Y? Right? If I know what X over Y is, I can find that value, divide it by 3, and get an answer. Okay. So looking at statement 1, is this sufficient? Can I get X over Y from this? Sure, right? If I get used to kind of moving these things around, it's a really common format, actually. You'll see an equation where you have 2 variables with coefficients set equal to each other, and this translates into a proportion. And you want to be able to translate back and forth between those, right? If you imagine doing this one step at a time, or don't imagine, just do, you might divide both sides by y. And then you could say, all right, well, now I don't want that 3 there, so I'll divide both sides by 3. And I'll get 4/3 equals X over Y. Sometimes we'll have the opposite situation. Maybe we'll have like a ratio set up. Like they'll tell us the ratio of X to Y is 4 to 3, and we'll actually cross multiply to get back to the form that we were given this time. So we might start with something like this and get something else like that, depending on what we're looking for and what our goal is and what other information we have. So here, I want to get this x to y ratio, so I'm going to leave it in this form. So notice that from here, if I wanted, I could find out what x over 3y is by dividing both sides by 3. But remember that I don't actually care what x over 3y is. I just want to know if I can find out, right? So this gets us x over y, and therefore it is sufficient. Okay. And in data sufficiency, when statement 1 is sufficient, that means the answer is either A, statement 1 alone is sufficient, statement 2 isn't, or D, either statement 1 or statement 2 would be sufficient. So I'd get rid of the bottom line BCE. That's just our general data sufficiency strategy. How about statement 2? Is that sufficient? Can I use that to find x over y? It's often very hard to get between different kinds of operations. So if I have a question that's asking me about division, and I see a statement that's about subtraction, addition, subtraction, it's going to be a bit harder. So if I try to put x and y together here, I can add x to both sides, but I'm going to get x plus 2y equals 10. And then if I try to do division, like if I wanted to divide x by y, I'd also have to divide 2y by y. That would cancel, but I'd also have to divide 10 by y. I'd end up with y in more than one place, right? They've told us y is not equal to 0, basically just to avoid any trouble with dividing by 0. It doesn't really matter much for our purposes. But this wouldn't get me anywhere. So I'm kind of stuck. There's not really a way to get from adding values of x and y to dividing values of x and y. So this will be insufficient, which means the answer is just A. Statement 1 alone works, statement 2 doesn't. So our speed strategies in practice here are first, making sure we're really clarifying what the question really wants from us. Once we wrote this down, what is x over y, we didn't think about w anymore. We didn't even really think about this 3 anymore. These are different answers, right? If I said, what's my age versus what's half my age or what's a third of my age, those are different questions. But if you know one, you can find the other. If I tell you my age, you can always divide by 3 or whatever you want to do, right? So if we know what x over y is, we'll be able to find x over 3y. And so if we simplify that, we are setting up so we don't have to do as much work. We're avoiding unneeded calculation. And we're not spending a lot of time testing cases when we don't need to. I love testing cases as a strategy when I'm stuck or when I'm trying to clarify something or figure out what works. But if I don't need to test cases, then I don't need to, right? Imagine I asked you, I said, my cousin was born in the 2000s. Is she more than 40? Would you test cases? No, you'd say 2000 was 23 years ago. That's the oldest she could be. So anything beyond that, she can't be. I don't test cases. I don't say, well, if she was born in 2007, right? So I only test cases when it helps me to clarify. If I don't need to do it, if I can just run some calculations really quick or, see that I just can't move the things the way I want to move them, then I can save myself a lot of time as well. Okay, questions, thoughts on that before we try some more? All right, let's try another on the theme of data sufficiency rephrasing and also just clarifying in general what we're looking for and what we have. We can also think about bad answers on this one. So we'll use a few of our different strategies. So take a moment to try this and see how you can rephrase this question. What are we really looking for? So see what you can do with just the question stem to clarify what's needed. Take a moment. So this one's interesting because we have both a factual statement. They tell us as a fact that Mn is greater than PQ. And we have a question. They want to know is if M over Q is greater than P over N. And those look kind of related, right? They have the greater than sign in both cases. They have some of the same letters in the same place. What would we need to know or do to get from this statement to this question? What's the difference, or how would we manipulate to relate these? Yeah, I've got to think about sign, right? Because what would stop me from just saying, wait, if MN is greater than PQ, why can't I just say, well, I'll divide by N to get that to the other side. And then I'll divide by Q to get that to the other side. And then I have exactly what they asked for. Now, talk about bad answers are too good to be true. This isn't even an answer. There isn't a data sufficiency answer that corresponds to, oh yeah, it's true. Yep, we know that before I even looked at the statements. That'll never happen because the answers are all about how much of this information do you need? And there's never an answer that says you don't need any of it. You already know. So there must be something wrong with this. And what I'm hearing is I've got to think about the signs. They told us that none of these are zero, and that's good because you can't divide by zero. But they didn't tell us whether they're positive or negative. And so if you remember your rules about inequalities, the idea is that if you divide by a positive number, everything stays the same, right? So if you know 5x is greater than 100 and you divide by 5, you just know x is greater than 20, and this is fine. But if I divide by the x instead, if I say 5 is greater than 100 over x, I don't know if it's true because I don't know if x is positive or negative. Well, actually, here I do because it's greater than 100. That was a silly example. But if I divide by an x in general and I don't know whether it's positive or negative, then I don't know whether to flip the sign. Here I would, because if x were negative, then 5x wouldn't be, greater than 100. So I have to be careful about that. When I divide by n here, I don't know if it should be m is greater than pq over n, or should it be m is less than pq over n. And then when I divide by q, I don't know if I should flip the sign again. So I don't know which sign I had. I don't know whether I have to flip it again. So I don't know if this is really true. So what would allow me to say this? What could I know about n and about q that would make this true? Here we might think about the two values separately, right? So what if they were both positive? What if they were both negative? Or what if one was positive and the other's negative, or vice versa, like this? If n and q were both positive, no flips, so it would be fine. If they're both negative, we'd have two flips. When I divide by n, I'd flip the sign to say less than. And when I divide by q, I'd flip the sign again to say greater than again. So we would be back where we started. Whereas if I have a positive and a negative, I'll get it flipped one time, and I'll get the opposite of what they asked for, right? So what I'm really trying to figure out then is, are they opposite signs or not? If these two are the same sign, then we can get this result, right? We get this result. If they are different, our answer will be no. That would still be sufficient for a data sufficiency question. We'd still know the answer. Oh, then it's not greater than that, it's less than that. M over Q would be less than P over N. But so that would be sufficient as well. We just need to know which one it is. What would be insufficient is if we don't know the relationship of the signs. So we can rephrase this to, do N and Q have the same sign? And a lot of folks won't do that, and then they'll end up struggling in the statements, wondering what significance they have. Now, before we go to the statements, there's something else interesting about them that we can look at before we really do much with them, which is that notice that one of the statements is about Q, and one of the statements is about N. So even without doing anything, with these statements. Just noticing that one is about Q and one's about N, what answers can we rule out? Yeah, I'm not going to be able to get by with just one statement. Sometimes the GMAT can be really tricky, and they might give you some way that it doesn't matter what one of them is. You know, if something could be zero or cancel the other, or maybe we don't realize that we have something more about the relationship than we thought, right? That could be one thing. But here, I really need to know the relationship of the signs. And so just knowing one of them isn't going to work. So what I then know is statement one isn't going to be sufficient by itself. That gets rid of AD. Statement two isn't really going to be sufficient by itself either. That gets rid of B. So this is one of those ones that's going to be either C or E. And I can do that without having done any work. And so again, this is kind of like avoiding unneeded work, but I am going to still do the work. So this is a bit of pre-work of looking at my expectations and narrowing things down. And even on data sufficiency, where we don't think as much in terms of narrowing, I can do a lot of that. I can say, oh, this is going to be a C or E. Sometimes it's the exact opposite. We can look at a problem and say, there's no way it's C or E. Sometimes that's just too easy, right? They would go so well easily together in C that proves that we can solve. It's not E, but it makes me very nervous about picking C. It just seems like that would be too easy a question. Here we have the opposite. We know it has to be C or E. Then we can look at what this tells us. If C cubed is positive, what does that tell us about C? When I cube a number, it doesn't change its sign, right? So cubing doesn't change the sign. If I multiply a positive times a positive times a positive, I still have a positive. If I do negative times a negative times a negative, negative negative is positive, and more negative makes it negative again, right? So I'd have positive 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 equals positive, and negative negative negative, like this, would be positive negative, which is negative. So it doesn't change the sign. And so if Q cubed, that's a mouthful, is positive, Q is positive. So that's not sufficient because it doesn't tell us anything about N, but it tells us Q is positive. Then I go to statement two. This also doesn't change the sign. So we know that negative N is negative, which means that N is positive. So Q and N are both positive. That's sufficient. That answers our question. Okay, it's a C. So by managing our expectations, what we're looking for, we can make this go a lot more quickly and easily. We still have to know the content-specific things about testing positives and negatives. If I don't have that content-specific bit of, hey, odd exponents don't change the sign, then I'd have to sit there trying numbers. Well, what if N was positive 2 and what if N was negative 2 and what would be the difference? So having the content-specific part is very important in speeding you up. If you're looking at this going, oh my gosh, this is overwhelming, or this would have taken me 5 minutes, then this is a time to drill in on A, data sufficiency technique, and B, those specific content bits about exponents and dividing through inequalities and things like that. So this is a hard problem because it has all those pieces. But if we break it down and expect those bits, we can make our job a little easier again. So yeah, question, why is N negative if N, I can't talk, if negative N is negative, then N is positive? Because a negative sign switches the sign. You can think of it this way. If negative N is less than 0, when we divide by -1, negative N turns into N, 0 stays 0, and the inequality switches. But you can also think of an example, like let's say negative N equaled -2, right? Then N would be 2. And if negative N equaled -5, then N would be 7, right? If negative N equaled a positive number, then N would have to be a negative number, and then it wouldn't be true what they said, right? Negative N could be 2 if we didn't know anything about it, but they've told us negative N is negative. So we have to set negative N equal to a negative number. Not because it has a negative sign on it, because they told us it's negative. If N were negative, then negative N would be positive. So putting a negative sign in front of something switches its sign. If it was already negative, it turns positive. If it's positive, it turns negative. Does that help? Okay, go ahead and chat your follow-up if you like. I know this is a lot. Okay. So while we're thinking about that, just kind of touching back on some of the things we talked about. First off, what do? We tried to rephrase, right? We were looking back and saying, hey, what am I looking for in this problem really? And that's part of the process of clarifying the question, but it's a specific thing to data sufficiency. We were even simplifying down within our rephrase question. This also involved making a solution expression. Hey, I want X over 3Y, or I just want X over Y. I did some prediction about what I'd expect in an answer. Hey, I need to know about N and Q. So I'm looking for something that gives me details to relate them both. If there had been an answer, if there had been a statement, I should say, that had N and Q in it, then it was at least possible, then it would be at least possible that it was sufficient. But if it just mentions one, it's just not going to be. We talked about learning some topic-specific things like odd exponents and what to do with them, like looking about flipping signs and interpreting positive, negative in that way, right? So a couple different things that we're trying there. Okay. So yeah, so then after that, we didn't input n into another fraction because we'd already decided what we wanted. And what I mean by that, if we go back to what we had before, just a moment ago, once we decided that we wanted to know whether n and q are the same sign, we never went back to any of these other fractions or equations, because what we simply said is, this will be true if n and q are both positive or if they're both negative. So I simply want to know. And just like on the last problem, when we said, hey, what's w? It's, x over 3y. We never thought about w again. I'm never going to think about m and p again. And I'm not going to think about this inequality again if I don't have to. I just want to know if n and q are the same sign or not. Statement 1 just tells me about q, tells me it's positive. Statement 2 just tells me about n, and with a little work, I can see that also tells me that n is positive. And so now that I know n and q are positive, I'm done, because my rephrase question was simply, do n and q have the same sign? I didn't plug back into anything else. I just said, this is what I want. And that's, again, it's a speed strategy. It's being efficient. It's saying, once I know what I want, I don't have to go back and find something else, right? I just know this is what I needed. Okay. Sure thing. Okay. Now, sometimes in problem solving, we try to narrow things down, and sometimes there's not a lot we could do, but we can think about even just, is there even one answer I can get rid of? Like, take a look at this one. Jason deposits money in a bank on a Tuesday and returns to the bank 100 days later to withdraw the money. On what day of the week did Jason withdraw the money from the bank? I might not be a fast enough calculator to immediately know what day it's going to be 100 days from Tuesday. But can you tell me really quick one day it's not going to be? We know that 7 days from then, it'll be Tuesday. And we know 14 days from then, it'll be Tuesday, and 21 and 28. Is 100 a multiple of 7? Is 100 a nice, simple number of weeks? In other words, can I make exact integer number of weeks out of 100 days? No. If I just get rid of that one answer, even that is getting me someplace. Why? First off, what if I calculate and mess up and get Tuesday as an answer? Now I know I'm wrong. 2, what if I'm out of time and I just don't have the wherewithal to figure this out? At least I'm guessing out of 4 instead of 5. So even if you're just looking for those little things, it didn't take us long to do that. It might just be part of your process. Well, I know it's not this anyway. And so you're keeping going. So I'm not saying, oh my gosh, this is how you should do the problem, right? Get rid of B and guess. But it's part and parcel to me of solving, because as I'm going, I'm saying, well, okay, so every 7 days will be a Tuesday. So the 7th day will be a Tuesday. And the 70th will be a Tuesday. And the 77th will be a Tuesday. And let's see, 70 plus 28 is 98. That'll be a Tuesday. Oh, look, 99 is Wednesday, 100 is Thursday. So I don't have to calculate, right? I can, and it's not a really terrible calculation. I could just say, hey, what's 7 into 100? And, if I don't know offhand, I could do, you could call it long division, or you could just sort of do your nearest multiple, but I can do this, sure, and subtract 7. And then it becomes like a remainder problem, right? Where I say, okay, what's here? I've got 30. 30 divided by 7, well, 7 goes in 4 times. And I've got 28, and I'm out of space because I didn't plan your space better than I do. And we have a remainder 2. And that 2 will be how many days past 14 weeks we have. So we had 14 weeks, but I don't really care that I had 14 weeks because I'm not asking how many weeks there were. But what I care about is it's 2 days past that. So 14 weeks from now, it'll be a Tuesday, and then there's 2 days past that, Wednesday, Thursday. But why do this work and interpret it when I just know, okay, 70 days, 70, okay, I can just maybe jump to something like this. Okay, so even if I can just narrow down one answer or use that to kickstart my thinking, just looking at the answer saying, I'm supposed to actually know. It's not like which could be or anything like that. They expect me to actually know. It must be something where I'm just counting sets of 7, right? There's not much else I could do. Here's another thing where we can avoid some calculation or some work and maybe even use some content-specific knowledge. Now, this is an area that a lot of people find really forbidding, combinatorics. In fact, it's an area that we've kind of kicked out of our course. If you take one of our courses, you'll get all the materials to cover combinatorics, but most teachers don't actually teach a combinatorics lesson in the class because it's kind of a rarer topic. I mean, it'll show up, but it's a smaller topic and it's got a steep learning curve. And a lot of people just find life's too short for combinatorics. There's other things to talk about. But if we know a little bit about combinatorics, we can start narrowing things down. And what we can see is all these involve factorials, right? The exclamation mark is just a factorial, like 12 factorials, 12 times 11 times 10 times 9, all the way down, right? And if we know one thing is that if I want to put, say, 12 kids in line, there are 12 factorial ways to do that. And if you look at all the answers, they're all built on 12 factorial. And that's what these solutions all have in common. Because when you are taking 12 people, 12 paintings, 12, whatever it is, 12 books, and arranging them or distributing them in different ways, the maximum ways that you might have to do that would be 12 factorial, because you'd say, let's say I have 12 friends and they're each getting one of 12 books, or I have 12 kids and I'm putting them in a space and line. I look at the beginning of the line and say any of the 12 kids can go there. And then who's left? Let's say there's 11 kids. So any of the remaining 11 kids could go there. And then any of the remaining 10 kids can go there, et cetera, all the way down to times 2 times 1, right? That's my 12 factorial. But anytime there's repetition or redundancy, I carve something out. So I, for instance, say, there's 3 people on the committee, but I'm not distinguishing them. I'm not saying, hey, there's committee member A, B, C. So, if Joe and Karen and I are on a committee together, it doesn't matter if it's me, Joe, Karen, or Karen, Joe, me. And so it's a lot less variety than when we have people online, because those arrangements don't matter. And we divide by that factorial. So one way we can very quickly, once we have some content knowledge, get rid of some answers is say, okay, I can see 12 factorials on the top. And if there were one that didn't have that, I would probably want to get rid of that unless it had somehow canceled. But usually the biggest number on top won't cancel because there won't be anything as big as 12 to knock out. There can be exceptions. There could be pieces that they've canceled out. But if they're writing all the pieces and not like working through the math, then that 12 will stay, and it did in all these. But I know it's going to be narrowed down, and I know it's not that. Now, what's a group that I know has some repetition? I know these 3 committee members are repeated. And so I know that my solution is going to have to feature a 3 factorial. That doesn't mean that's my answer, but I know it's going to have that because there's 6 different ways to arrange those 3 people, right? ABC, ACB, BAC, BCA, CAB, CBA. There's 6 ways to arrange 3 people, and we're going to divide by that. So anything that doesn't divide by a 3 factorial is also out. And I don't have to be the master of all that is combinatorics. I can be wrong about some parts to do that, and now I'm down to 2. And then I have to simply say, what am I dividing by? 7 or 5? Where do I see a 7 or 5 in this problem? There's 12 students. There's 3 on the committee. There's 9 others left. I see a 9, but there's no 9 here. Where would 7 come from? 7 would consist of taking out the president and the vice president and dividing by the remaining people. Whereas 5, that would be like putting these 3 and these 2 together. Where does a 5 come from? I don't see how a 5 features in this problem, right? Because these 3 don't go with those. So if I really have my combinatorics down, I might then recognize that B is the answer. But if you don't like combinatorics and you can still get down to 2 here, that would be a win. Right? So in this case, the full solution would look like I'm going to divide by 3 factorial for the people who are on the committee. And technically, if you want to be a real nerd about it, I'm divided by 1 factorial for each of the singular positions. That's 5 positions, and then 7 factorial for the 7 students that don't get on anything. So it would look like that. Of course, we don't put the 1 factorials because they don't do anything. So we end up with B, but we might not have to do all the work to get there. Questions on that? Okay. While we're on the theme of avoiding work, what about something ugly like this? A lot of people, if they were on the test and they were short on time and they knew that, they need to drop something, I would say, hey, if you see this, don't do it, right? This looks not fun. I mean, might be an enjoyable challenge, but it doesn't look like something that's going to go down really quick and easy. So what I might think about is there any way to save time? If I'm going to drop it, I'm going to drop it, and that's fine. And like I said, that's a big part of your strategy. But is there a way to avoid dropping it? Well, I noticed that everything on the right, all this stuff on the left equals on the right just 32. How can I relate the number 32 to this stuff on the right? What's another way I could write 32? Uh-huh. 32 is 8 times 4. And I see an 8 in the problem. I don't see a 4. Can I take it any further? I can keep breaking down to 2s. 8 times 2 times 2. Right? I have a lot of 2s and 8s on the left. If I could do this as a power, that would be great. I can do 8 as a power of something and 4 as a power of something, but I can't combine those very readily. So what if I just wrote it as 8 is 2 to the 3rd, and 4 is 2 to this 2 squared, right? And then when I put those together, it's 2 to the 5th. Now, if I have that recognition, and it's nice to know some of your powers of 2, that it's 2 to the 5th, I can even save that time. And recognition is a big part of this test of just saying, oh, I've seen that before. Some people overdo that. They're like, I get to memorize all my powers of 2, 3, 5, and this up to the 10th. Okay, wow, that's overachiever. You might not need that. There might be better things to do with your time. But a lot of the things that I have memorized like this are not things that I sat down with flashcards to do. It's just things I got exposed to enough times that I just couldn't help but remember them. So sometimes I kind of disingenuously say that I count 2s on my fingers. That's not quite true, right? It's more that I know them and I'm using my fingers to track. I'm saying 2, 4, 8, 16, 32, right? I keep going 64, 128. I might have to think about some of them, but at this point, I don't. I've really got those memorized up to a certain point. You might have to think about them if you don't have them memorized, but you might find that you can actually do that pretty readily. Now, the advantage of this, once you have that, is you can say, look, if all this stuff on the left turns out to just be 2 to the 5th, if that's what the value is, I've got all these other numbers like 27, which has no 2s in it, right? 27 is 3 cubed. And I've got 50, which has 5s in it. I must not need to worry about any of the things other than 2s because they must cancel out. Can you see that? If 27 is some power of 3, there's none over here. So whatever's on the bottom must get rid of it. All I need to pay attention to are the terms with 2s in them. Can we buy that? So I'm not actually proving that this divides out so much as knowing that it must. So I could say, that term has no 2s in it. 8 does, 50 does, but only partially. 2 to the y does, 25, no twos. 54, huh, what's 54? 54 is 2 times 27. So if I have 54 to the x plus 2y, I can apply that exponent to both of them. That's going to be 2 to the x plus 2y and 27 to the x plus 2y. But this part, I don't need. In fact, we can see that it just cancels with what's on the top like we predicted it would. And so I could do that out, but I can also just recognize that all I need here is, that's too big, is 2 to the x plus 2y. Am I being a little weird? Am I being crazy? I don't know. But the idea is that I'm saving myself some work by saying, hey, if all that's on the right is 2's, then everything else just must work itself out, and I'm not going to think about it. It's almost like when you watch a movie when you're a kid, like a Disney movie or something like that. You know the main character is going to live. Why? Because it's not that kind of movie that, they're not going to kill off the hero of the story, right? And so you don't have to worry about that. You just know certain things are going to work out. Here, it's going to somehow work out that all the 3's and the 5's are going to disappear, and we're going to be left with nothing but 2's. So let's just pretend that already happened. Let's just get rid of all those things. Here, I've got 25 and 2, so I'll just call this 2 to the 2x. If I actually do the work, I'll see that those cancellations I did really do work out, but I don't have to think about them. I can just say, hey, this is going to be 8 to the y times 2 to the 2x over 2 to the x plus 2y times 2 to the y. It's kind of a mess, right? But it's a lot less of a mess than it might have looked like. Got this now. Okay. Questions on that so far before we proceed? If I keep predicting, I might also know, they're asking about x. There must be a way to find x. Y must somehow go away. But I can't just cancel all the terms with y in them too readily because I've got them in different places. Some of them are added to x and some of them are not. So I'll have to kind of put this together. I have one of these that's still an 8. So I'll call 8 is 2 to the third. Okay. So I'll have 2 to the third to the y. It's a lot, I know. If you haven't done this stuff in a while, this is probably looking not terribly friendly. But I'm getting rid of the work I don't have to do, and that's what I really want to stress. These on the bottom, since they have the same base, I can add the exponents. 2 to the x plus 3y. The rule is that when you have a power to a power, you multiply. So on the top, I'm going to have 2 to the 3y plus 2x. On the bottom, I'm going to have 2 to the x plus 3y. When I divide, I subtract exponents. So I could write that all out, or I could just say, oh, these 3y's are going to cancel. Right? I can write that though. I can say this is going to be 2 to the 3y plus 2x minus x plus 3y. Maybe this is giving you a headache, or maybe you're like, hey, I'm following along with this. My studies are paying off. Great. I know these are for folks at all levels of preparation, try to keep everyone happy some of the time, and maybe some people are miserable some of the time. So this is all just 2 to the x. So what are they telling me? This whole thing on the left is going to cancel out to 2 to the x. So what do I have? 2 to the x equals 2 to the 5. Means x is 5. So still a lot of work. And if I made it look like this was going to be easy and simple, well, it wasn't quite that. But if you have these moves, you can do that without having to worry about all the 5s and the 3s very much, right? And focus on what we really know. Okay. Questions on that? What I always hope is that no one looks at my work and just goes, hey, wow, that guy's good at the GMAT. Yeah, great for me. It doesn't do anything, right? It's got to do something for you. And so I hope that you are already feeling better at the GMAT than you were when you started. Not just today, right, but in general in your studies. But we can always keep growing. And I think a lot of that is, how do I take my general strategies like simplification, some general principles, and then how do I apply them in a particular case, right? And that's like anything. I can take the most simple instructions for life, like when you're dealing with others, be kind and listen. right? Okay, but how do you be kind and listen in different situations? What if you don't speak the other person's language very well? What if you're deaf or they are? What if you don't know how to be kind to them because you don't know what they want, right? There's complexities we have to deal with to navigate even simple things like be kind and listen. So when I give you really simple advice, like, make sure you're clarifying the question and make sure you're, front loading your efforts and all those kinds of things. The on the ground version of that often involves what are some topic specific things. Of course, naturally, we all know that we want to know our rules. Do I know how to simplify exponents? Do I know how to relate? Do I know how to break down numbers to their prime factors? But then it's using that to fit with these broader principles of, am I simplifying the question? Am I looking for what I can expect? Am I trying to find active ways to save time and trouble? And it's not in that sense that some people think that, hey, when we GMAT test teachers, take a test, we have a cool, clever shortcut for every single problem, and we solve them all super fast and super accurately. I wish. I need all the time I can get on the GMAT, and I'm still saying I'm struggling for time. The test gets harder as you do better, and it is a hard test, period. So even when I look at a maybe middle level accuracy or a difficulty problem, I don't necessarily say, oh, of course it's this, right? I wish. But it happens some of the time. And if even 10% of the time you find a clever thing that saves you some time, then that gives you more room to breathe elsewhere in the test. And if you have enough little tricks that you save 10 seconds here and 5 seconds there, that itself can add up, right? So we're looking for all those little things that can make a difference, right? And it's often those little things that really do constitute any experience. You go to a fancy hotel. Well, it's got rooms with beds and stuff, right? It's how different is it? But maybe it's those little parts of your experience that make you think, wow, this is nice, right? Ooh, these towels are so soft, or whatever it is, or hey, I called downstairs and they were immediately helpful, or whatever that thing is. And so it's those little tiny differences you can make to your performance more than just, becoming the greatest mathematician of all time. Not necessary, not something that's on most of our agendas, right? So look for these little ways to adjust, little ways to get faster, more efficient, more accurate. And that's really where growth tends to come from. All right, folks. Well, I hope you found that helpful. I will invite people, if you haven't already taken a course, to check out one of our courses. You can always do any of our courses as a trial for the first class and see what you think. Check out any of our instructors. Love to stick around and answer any questions that you have personally. But other than that, thanks so much for coming, and I wish you all the best of luck with your exam. Thanks, folks.